Hey guys, this video is for 6.4. In 6.4, we are dividing with decimals. So for this first example, you see, how many times can 5 go into 19? There's no decimal here, but don't worry, it's coming. You'll see it as we go through. So, can 5 go into 1 is our first question. No, it cannot. I have the kids write a little X. Then they ask themselves, can 5 go into 19? Yes, it can. Now you have to think to yourself, well, how many times? So for the kids, I tell them to count by 5s. So if they count by 5s, 5, 10, 15, 20. Oh, the fourth one would be 20. 20 is too big, so 5 can go in 3 times. 5 times 3 is 15. They would subtract it out. Then they're left with a 4. Can they just say, oh, it's going to be 3, remainder 4? Are we allowed to do that now? Now that we're dividing with decimals and we're not supposed to have any remainders anymore? Nope, you can't do that. Can you say, oh, well, 4 is last. I'm just going to say it's 3.4. Can you do that? Nope, you can't just say it's going to be 3.4 either. You have to think to yourself, when this happens, what I need to do, I add a 0 behind the dividend. I bring the 0 down. Now it becomes 40. How many times can 5 go into 40? Well, I know that 5 times 8 equals 40. Subtract it out. Nothing's left over. Now I'm left with 38 at the top. But is the answer really going to be 38? Because the real equation was how many times does 5 go into just 19? So here's where it gets a little bit complicated. My original problem was how many times can 5 go into 19? In 19, we don't see a decimal. There's no decimal written, but there's really actually an invisible decimal that should be behind 19. Anytime we cannot see the decimal, it is hiding right at the very end. So when we're doing our division problems and the decimal is hiding, we need to make sure at the very end we go back and place our decimal. The original problem was with 19, not 190, so my invisible decimal goes there. Now, anytime we're dividing by a decimal at the very end, our decimal place always goes straight up. It doesn't dance, it doesn't go over here, it doesn't go hop, skip over there, it doesn't choose it's going to go back here, over there. It goes straight up every single time, no matter what. So when it hops straight up, it's going to be 3.8. So that is your answer to this one. Let's try another example. All right, and in our next one, we're going to have 35 and 5/10 divided by 5. First thing we ask ourselves, can 5 go into 3? Nope. Can 5 go into 35? Yes. If I count by 5s, 5, 10, 15, 20, 25, 30, 35. 7 times. 7 times 5 is 35. Minus it out. I'm dividing like normal. I'm not thinking about the decimal. I'm dividing like normal all the way through till the very end. Next thing I would do is bring down this 5 that's hanging out here. How many times can 5 go into 5? 1 time. 5 times 1 is 5. Minus it out, I have 0. This time I'm left with 0 at the end, not some crazy number. So I don't need to do that 0 craziness and bringing down the zeros. If I'm left with 0 at the end, that's it. I'm done. It's over. Now, I look and see where I place my decimal. Remember, my decimal always goes straight up. It doesn't do a dance. It doesn't come forward. It doesn't come backwards. It goes straight up every time. So my decimal is going to come straight up. And it's going to be placed right there. 7.1 would be my answer for this equation. Let's try another one. If I have 33 and 8/10 divided by 4, first thing I ask myself is, can 4 go into 3? No, it cannot. Can 4 go into 33? Yes, it can. So now I'm thinking, 4 times what is close to 33? Well, I know that 4 times 8 is going to give me 32, which is the closest I'll be able to get. Subtract it out, I'm left with 1. Then I need to bring down my next number, which is an 8. I asked myself, how many times can 4 go into 18? Well, the closest I know is 4 times 4 would be 16. I minus that out and I'm left with 2. I have something sitting over at the end, this 2. I can't say the answer is going to be 0.2. Nope. I can't say the answer is going to be remainder 2. Nope, none of that craziness, I can't do it. What I'm going to do is the trick where I have to add my 0 in my dividend and bring my 0 down. Now I have 20 at the end. Can 4 go into 20? Definitely. 4 can go into 20 5 times. 4 times 5 is 20. Minus it out. I have nothing left over. Now I'm done with my equation. I have to place my decimal. My decimal does not do a dance. It doesn't go crazy. It doesn't go over here, over there. It's going to go straight up every single time, and my answer is going to be 8 and 45 hundredths. Let's try another example. What if I had 13 divided by 2? So here's an example where it's a whole number, but it's going to end up being a decimal as we work through it. Can 2 go into 1? Nope. Can 2 go into 13? Well, yeah, of course it can. I know that 2 times 6 would give me 12. Minus it out, I'm left with 1. Can I say, oh, the answer is going to be 6 remainder 1? Nope, remainders don't no longer exist anymore. Oh, can I say, just kidding, it's going to be 6.1? No, I can't just think it's got to be 0.1. I got to work it out. By working that out, I add my 0 to the top. I bring my 0 down. Now I see a 10. Can 2 go into 10? Yes. 5 times. 2 times 5 is 10. Minus it out, nothing's left. My problem is right here. My original equation was 13 divided by 2. 13 is a whole number, so that means that my decimal's hiding in a certain place where it's invisible. Anytime it's invisible, it's always hiding in the back. So my decimal's actually here. So now I need to place that up here because it was 13 divided by 2, not 130 divided by 2. Now I have my decimal. It does not do a little dance. It does not shake over here, go over here. Every single time it goes straight directly up. And my answer for that equation would have been 6.5. All right, guys, just so you know that you have a quiz coming up on Friday. And this right here is going to help you. It's going to be a quick, short 4 questions. And it's going to look like some of these questions. Thank you, guys.